Good afternoon, YouTube. This video is going to talk about platform-agnostic container environments and how we can use DNS to round-robin traffic or potentially move workload between two container environments. You'll notice that these two container environments in this specific demo is OpenShift and Kubernetes. So we have two environments, one being OpenShift 4.9, an entire cluster, and another cluster of Kubernetes version 119. And what's really cool here is that the ingress resources are completely common, meaning that they're pretty much the same. There's only one specific difference. And so why this is cool is, most organizations today are deploying multiple environments, even yourself. There are multiple potentially Kubernetes or OpenShift environments, or you might have one Kubernetes and a different type of cloud environment. It could be OpenShift, and potentially maybe you want to distribute traffic. Why? Because multiple environments can definitely improve availability, potentially maybe some isolation. Maybe you want to do some proof of concept. You're not quite sure whether you want to adopt a specific technology right away. So maybe you can kind of look into it, do a proof of concept, maybe move some stuff around, kind of see what you like, and then kind of pick and choose from that way. And to try and find and integrate with a platform agnostic environment or an ingress controller kind of gives you the benefit there. And in most instances, big IP is already there. And so we're potentially leveraging big IP on-prem or potentially in the cloud that could be there already. So in this guide, we've deployed OpenShift and Kubernetes, and they're running the identical applications. So I've deployed the applications in both locations, so those apps are the same. Big IP is completely platform agnostic in here. It doesn't matter whether you're using Kubernetes or OpenShift. We're integrating with the CNI in both of them. We're using OpenShift SDN for OpenShift. We're using Flannel for Kubernetes. It's both VXLAN based. And we're going to use DNS to distribute the traffic between either Kubernetes or OpenShift, or if we want to take one location down, maybe you want to do maintenance, you want to upgrade your Kubernetes cluster, you can go ahead and take them down just by replicating the pods, which is I'm going to show you, and then you can automatically move the traffic to OpenShift. And you can do that vice versa. So this is actually kind of cool because it's a little bit different than only having one cluster or trying to figure out how to move traffic to different clusters. And so there's a lot that goes in here. There's a lot of different pieces, and specifically around the infrastructure platform. And we'll talk a little bit about that and some of the stuff that goes into this diagram. So CIS uses the Kubernetes API. It's a common API. So therefore, the resource definitions are literally identical except for the public IP. The public IP within Big IP is going to be different for Kubernetes as it's going to be for OpenShift because the IP address spaces are different. And really, that's the only thing that's different. The wide IP or the FQDN is the same for both. And at that point, the Big IP DNS is going to do the load balancing. So when we deploy this, we have to use these big IPs, and we have to set up the big IPs in almost like a mesh. And we have something called iQuery, and what that does is that replicates the configuration, it replicates the state between the two big IPs. And so within your configuration, once your DNS configurations are online and configured, and you've created your two data centers, right? We have data center Kubernetes and data center OpenShift. You can kind of see it here. That's what will show up when you've synced your configurations on your GTM. So let's go take a look at what that looks like. You can see here, in my case, my big IP LTM and my big IP DNS is on the same device. Right? They can be different devices. It doesn't matter. Just doesn't change the configuration that much. But you can actually see here. Here is my one device. This happens to be Kubernetes. This happens to be OpenShift, and you can see that the data center there, and it has a server for both. So it's replicated in both. You can see the state. It's able to connect. So what's happening here is that the big IP DNSs are able to keep track of themselves and their if you want to call it, associated big IP DNS. So they can kind of keep track of each other. They can determine health of the applications and what is the best DNS answer to give out. And that's the most important thing. These DNS systems, this mesh that they create, is really important so that they know the health of all of the apps, right? Or they know the health of the, let's call it the public IP or the wide IP, because that's what you're going to give out to the client. And you're either going to give out an A record for OpenShift, or you're going to give out a record for Kubernetes, and potentially you can round robin, but there's manipulation that you can do within DNS to prefer one over the other, or bleed traffic into one, move traffic from one to the other. That's all part of DNS. We're not going to go into that too much because it's really outside of the discussion of this demo. So one thing you need to do is you need to deploy CIS in OpenShift. This is pretty much the manifest to do that. It's pretty simple. You'll notice here that you're going to communicate with Big IP local and GTM on the local device. We're using just a generic namespace. Here we're using cluster mode, and there is my OpenShift SDN connection. We are using CRDs. So we're not using OpenShift routes, and we're using CRDs because we're using DNS. So we're going to create 2 CRDs. We'll talk about them in a minute. And so once you've deployed CIS in OpenShift, then you can deploy CIS in Kubernetes. Very similar configuration. There's really no difference. The only difference here is the IP addressing, right? Because this is going to talk to the big IP in Kubernetes versus OpenShift. CIS is going to talk to the big IP in OpenShift. The difference here, of course, is the clustering of the CNI. We're using flannel here. There's the flannel tunnels. There's lots of information that talks about how to create this. So the next important item is creating the CRDs. So here is a CRD. It's unsecure, so in this case, it's port 80 all the way through. It doesn't matter. You can make it secure. You can do edge. You can do re-encrypt. That's fine. chose to do unsecure. We are monitoring the backend. So for example, we're monitoring both paths for coffee and tea. Here's just a tea example. You can see I'm monitoring the tea service. There is my tea service right there. There is my host name. Here is my IP address. Now the IP address for tea and coffee are the same. So I'm doing that because I'm doing host header load balancing utilizing this host group called Cafe. And here is my FQDN, and that's basically my host header. And you'll notice that the domain name has the same host right there. And because it's external DNS and it's one FQDN, this is not per app. This is basically one FQDN with multiple backend paths. So there's multiple potential apps or pods running off this one host, right? And so cafe.example.com has a tea app and a coffee app. It's 2 different deployments, 2 different replicas, right? So here what's really important is that I need to probe either tea or coffee. If you don't want to do that, you can do per app, which is much easier actually. But when I'm creating multiple applications behind one FQDN, such as tea, coffee, I have to create monitors, right? And if one monitor fails, we remove the wide IP. That's really important. At this point, it's if one fails, then we remove, not necessarily if all fails, right? So, get some feedback. This is the first time that we've written this. This is brand new code for CIS 2.8. You'll see monitors now in the schema. And so this is actually kind of nice because it allows you to do this. One important thing is that you need to have a discussion about monitor scaling with your solution architect from F5, just to make sure that you don't exceed the critical number. There is a number of monitors, but here's only 4 monitors potentially per device. It's nothing, right? This is also HTTP monitor, so it's really important that you have that discussion with your solution architect, specifically if you're getting into 100 to 1,000 apps or 1,000 apps, right? For example, so that's really important about the discussion. So you can kind of see here is the LTM load balancing virtual server, and here is the DNS or wide IP part of it. This is actually kind of cool. This is your external DNS CRD. And so you don't have this with OpenShift routes. That's why we're using CRDs. So you can create your schema. Really important to create the schema. Create your VS, your virtual server T, your virtual server coffee, and your eDNS CRD. And if you can do an OC get CRDs VS external DNS, you can actually see that they've been created. You've created it for that domain. It actually shows you the status. The status is actually okay. That means that the policy has been created, right? So we have one FQDN. You can see there's one IP address, 125.121. There's one IP, but there's two policies. One policy is for coffee, one policy is for tea. And so it's basically policy-based load balancing or HTTP routing, and that's how it's working. And the 200 OK status here is basically saying that yes, the policy is created back from big IP. That's a status code that CIS gets to determine that the policy is actually in place, and that now we can create the wide IP, and this is what's configured under DNS. And so this is for Kubernetes, so we're going to do the same thing. Remember, we talked about a common API here, the common configuration between the two. The only difference is the public IP virtual IP address. This being, instead of 125, this is 75. I know, it's kind of a mouthful because they look so close, but I kind of mirrored that way. But the other only difference is the data center, right? This is K8S and the IP. That's the only difference. Other than that, everything is absolutely identical, which is actually kind of cool. That's why it's really just platform agnostic. It doesn't really matter to CIS because it's using the Kubernetes API. That's what makes this so cool. And so the same deployment goes here. You can deploy, you can see Kubernetes, kubectl, get, you can see them here. It looks very similar. There's really no difference between the two. And of course, if you want to pull the IP address down, you can see 75.121. It's Kubernetes. And this is the virtual server deployment Kubernetes. So now let's take a look at the public. Let's take a look at the wide IP. So you can see the wide IP here of cafe.example.com with two pool members. So let's log into one of these systems. We can see it a bit better here. So here is the wide IP. This is Kubernetes. And you can see here cafe.example.com. And here is the pool members. There's two pool members. So one represents each data center. And so 19 and 43. 19, I believe, is OpenShift. And so you can see here's all the monitors. The monitors are added, some default values. And you can see here, yep, it's OpenShift. That is the local LTM IP address, 121.80. And it'll actually tell you here that it's healthy. You can obviously see some statistics. Some statistics is preferred there. I think these are some of the load balancing algorithms on that. And so if we go back to the pools again, servers, you can see the two servers here. Let's go back to the wide IP. There we go, pools. So you can see the two pools right here. This is the second one, and the second one here is Kubernetes. So both systems should show the same. There is cafe.example.com, and that's on K8S, and here's OCP, and it says cafe.example.com, and there's two pool members. So you can see the pools. There's the two pool members there, and there's the two pool members here. Well, that's actually really kind of nice. So if I connect to the app, I don't know where I'm gonna go. Let's try connect cafe.example.com/t. It's unsecure. I went to 129. So 129 I know is OpenShift. And so I resolved DNS, went to OpenShift. If I close the browser and try reconnect, if I try open another app, go to coffee, I'll probably stay on because I don't have to go back and ask for DNS again. It's all based on DNS. So if I make this coffee, the host name is the same. So 130. It's a different pod. It's a different pod. So that's how I know 130. You can actually see it here if you go into OpenShift, and if you actually go to LTM, and if you go to pools, if I go to the right tenant, I can actually see the pools of coffee and the members. This is the local members. You can see 129 there, 130, right? 130 to 039, which is that, right? So that tells me I'm going there. Kubernetes is easy because it's always going to be 10.244 because that's the default flannel subnet. Let's go pools, change to K8s. And you can see, let's just go coffee here. These members, these are the local members. Yeah, 10.244. So that's how you know. It's it's kind of interesting. You can build something in your page if you want to determine where you are based on your location. There's lots of things you can do. I'm just using some default app, but that's kind of how I know. So everything is up. If I bring up a different client, I'll connect to a different one. You can look at the DNS statistics to kind of see where you're going. You can see here there's a total of 4 requests. 2 are resolved here, 2 are returned to DNS. So return to DNS basically means it's not available. So return it back to DNS because one of the sites are down. So therefore DNS will requery for a different location. So that's pretty cool. That's the setup. Let's go and bring down one of the locations. And let's see what happens when I bring down one of the locations. So what I'm going to do is I'm actually going to go into Kubernetes and I'm going to scale. I'm going to scale one of these systems down. So let's do a kube CTL scale. Okay, so let's change coffee. Currently it's at 3 replicas. So let's change the replicas from 3 to 0. Okay, so we'll change coffee from 3 to 0. So that means it's going to have the pod. What I'm doing is I'm actually replicating the pod down. So to make sure that the status is actually detected all the way from DNS all the way through to the pod. So there I scaled it down. And let's scale down T as well. So kubectl get pod. There should be no pods. That's correct. There's no pods there. We still have the virtual server, but we should automatically detect the failure. So we go back to Kubernetes. We can go to local traffic first. You can see that there is still the virtual server. We can try out our resources. We can see the virtual server is there because the configuration is still there, right? Virtual server is still there, but we can go to the pools and we can see that these pools are down. There's no members in place, right? So what's happened is service discovery detected that we scaled those replicas down to 0, and therefore those pool members are gone, which is exactly what happens, right? So this is on the local traffic side. So it's detected on the local traffic side based on your CRD. And so if we go to DNS, take a look at our pool members, you can see that one of the sites are down, and you can see that there's no pool members available. And so if we look at the pool member, you can see the pool member has failed. And the status is one of the monitors has failed. The monitor for cafe, the state, has actually failed. So there's a protocol mismatch. And so therefore we weren't able to make the handshake, right? We weren't able to get the status response that we needed. And so therefore it failed. And so now that's kind of critical. That what we have is we have one location that is down. So we will not be able to give out to Kubernetes. We'll still be able to successfully. Unfortunately, I was going to OpenShift before, and you'll probably yeah. I mean, you'll just continue to go to OpenShift. You'll continue to 129. These are all going to OpenShift again, because I hadn't connected to Kubernetes in the first place. Unfortunately, I wish I'd connected, but I wish I'd connected to Kubernetes, and then I could have showed that to you. But yeah, I'm still currently on OpenShift. So it didn't affect the users that were currently on OpenShift, but anybody that was connected to Kubernetes would have had to move to a different site. And so that's kind of how that works. If I scale those replicas back up again from 0 to, let's say, 4, let's do that. Let's change the replica number. let's go from 0 to 4. So there's tea. Let's do the same for coffee. There we go. So those replicas are changed. And then what you'll see is that this thing will sync up and will all come back online. You can see coffee's coming back. So it'll come back in a few. You can see that there is some members there. Those are all scaling up. So those pool members, coffee, let's go take a look at Kubernetes to make sure that those pods, CTL, good pods. So you can see that they were running, coffee and tea, so that they all come back up. Should all come back up in a minute here. And then your virtual server will be back online, and then it'll all replicate back up to the DNS. And so we'll be able to hand out. You can see that both pods are up now. And so if I close the browser, let's see. Let's close the browser and let's try reconnect, reopen the browser. Let's see what we get. And we got Kubernetes. That's pretty cool. So you can see there we went straight into the Kubernetes cluster at this point. Let's try that. Let's scale those down again, just for grins, because I'm in Kubernetes. So let's just put those 4 to 0. Let's do this quickly, and then I know this video is going long, but why not? Let's remove. So I scaled those 4 down to 2 again. So we're on Kubernetes. Let's give that a minute, and then let's see what happens. Let's see what happens here. Let's open a new one. Let's open a new one here for cafe. Let's open tea. Let's see. Okay, so there's still Kubernetes there. So the site has failed. So it should go back. It should go back to DNS. I might have to. There we go. 129. That one went back to DNS. That one now reconnected back over. So there's, as the DNS moves, the browser extents go back to DNS and then re-query, and you can actually see right there I'm back right again. So that's how this demo works. This is really cool using DNS with multi-clusters. Again, it's from a CIS and big IP perspective, we're completely platform agnostic. It doesn't matter whether it's Kubernetes, Tanzu coming in 2.8, whether it's EKS, whether it's on-prem, off-prem. It really doesn't matter. We're completely vendor agnostic in that case, and we're going to work with potentially all vendors under some specific standards. Most of it is CNI based, right? That's really important. So that's what I wanted to demo. Let's go back to my GitHub repo. So I have created this GitHub repo. So by all means, clone it, pull it, use this guide to kind of help you with this architecture. All the files that you need are all here. So everything is here. You can clone it. All the manifests I use for Kubernetes, everything I use for OpenShift is all in this repo. So by all means, pull it down. Appreciate it. Don't forget to subscribe, like this video. This took a long time to create. There's a lot of moving pieces here while I was doing some testing to make sure that you guys have this content. So it kind of helps get this content out so that other people can kind of see what's kind of going on here in the Kubernetes space. I really appreciate that. And let me know if there's something that you would like to see. I'm really excited about CIS 2.8. This is one of the CIS 2.8 features here with the monitors. And I will be presenting and recording ingress link with external DNS coming up later this week, maybe early next week. So thank you. Have a good day.